Alright, and let's finish this up. We're going to start here with number 33 and go forward to number 46. And then we should be all set and you should be ready for your test. What does the Lewis structure of thallium look like? So we've got to go to our periodic table. We've got to find thallium. Remember that we're ignoring the D and the F block here with Lewis structures. It's going to have 1, 2, 3 valence electrons. So we're going to go thallium. 1, 2, 3. We do not go 1, 2, 3. No, 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 no. Okay, we want them separated. We don't sit on each other's laps until we have to. Number 34. How many lone pairs does selenium have? Selenium is right here. So it has 6 valence electrons. So we go selenium 1, 2, 3, 4, 5, 6, and we have 2 lone pairs in selenium, so it will bond twice to something else. Number 35, what would the Lewis structure to ammonia be? So we have NH3 for ammonia. Nitrogen has 5 valence electrons. Hydrogen has 1 valence electron. Always start with the one who needs the most bonds, so remember our honk rule. 1, 2, 3, 4. Nitrogen wants 3, hydrogen only wants 1, so we're going to start with nitrogen. 1, 2, 3, 4, 5. And then we'll just plug our hydrogens in those empty gaps. Right there. What would the Lewis structure of water be then? Water is H2O. Oxygen has 6 valence electrons. Hydrogen has 1 valence electron. So we draw our oxygen with its 6. Our water with its 1. Okay, what are the 5 geometries? We have linear, we have bent, we have trigonal planar, and trigonal pyramidal. And lastly, we have tetrahedral. What are the 3 major angles? Linear is 180 degrees. Trigonal planar is 120 degrees. Tetrahedral is 109.5 degrees. And trigonal pyramidal and bent are both just slightly less than 109.5. If you just write 109.5, I'm great with that. So there's that. What is the name for MgO? This is all by its lonesome, so we just call it oxide. We just change that to its end. And magnesium keeps its name, so that is magnesium oxide. What would the chemical symbol for osmium 2 nitride be? Well, my osmium we know is 2 plus because it's written there in the Roman numeral. Nitrogen we know from writing it out before is 3 minus, so we're going to switch these 2 signs down, and so we'll get osmium 3, nitrogen 2, osmium nitride, osmium 2 nitride. All right, 41. What are the chemical symbols for the following molecules? Titanium with a charge of 2 plus, and nitrate, NO3, which has a charge of 1 minus. We have to balance those out, so that goes there. The 1 goes down, again, just down like this. So we'd end up with titanium nitrate. 41B is rubidium carbonide. Rubidium is a 1 plus charge. Carbonide is a plus 4 or minus 4. In this case, it'll be a minus 4. We switch those down, so RB, C, RB4, C1. Lead 2 phosphate, so PB, it's got a 2 charge. Okay, remember CNN, charge, not number. Should have said that on the other 2 as well, but that Roman numeral 2 is not the number of leads I have, it's the charge of the leads that I have. Phosphate is a 3 minus, switch those 2 around, and we go PB, yeah, PB3, PO4, 2, lead phosphate. What are the chemical names for the following symbols? Sr, CO3, is strontium carbonate. Okay, that one's really simple. We don't have to worry about a Roman numeral because this is one of my first two groups, and we don't have to worry about it with those. My next one is copper cyanide. And we do have to worry about that now because this is a transition metal, so we look and we have cyanide has a charge of -1, and I have 3 of them, so this is -3, so my copper has to be a +3. Tantalum phosphide. We know that it's phosphide because there's no oxygens in it, and if it's just a single type of atom, then it just goes IDE on the end. We know that that phosphorus has a -3 charge. There are 2, so that's a -6. We know that tantalum has 3 of them. It has to make a +6, so it's going to have a charge of +2, so tantalum 2 phosphide would be the name of that molecule. Drawing the Lewis structure for acetic acid. We did this in our lab with all the smells. So we have like that would be its Lewis dot structure. This is linear, 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 and linear. All my hydrogens are linear there. This carbon is going to be tetrahedral. This carbon is going to be trigonal planar. This oxygen is also going to be linear. And this oxygen is going to be bent. So actually let me go through and label these. Red is bent. Purple is linear. Black is trigonal planar, and blue is tetrahedral. So lots of different shapes here. Bond angles that are going to go with those is 109.5, 120, 109.5, less than 109.5, and 180. Okay, number 45 and 46. I have 25 moles of oxygen. How many grams of the above molecule do I have? The above molecule is that acetic acid, that CH3COOH. So I'm just going to set up my table, 25 moles of oxygen. Okay, I've got to switch substances. So I'm going to go in 1 mole of O, I have 1 molecule, or sorry, 2 moles of O, I have 1 molecule of CH3COOH. Right? See, I've got my 2 O's here. So in 1 molecule of this compound, I have 2 oxygen moles. Sorry, it should have been 1 mole of COO. Yeah, sorry. 1 mole of CH3COOH is 2 moles of oxygen. Okay, if I cut off 10 heads, then I have 20 eyes. There's 2 eyes per head. Same kind of idea there. And then I'm going to switch from 1 mole of CH3COOH to grams, and this is going to weigh 60.06. We're just adding all of those numbers up. Times that out, 750 grams of acetic acid. All right, and this is 2 sig figs, so I can only have 2 sig figs in my answer. My last one here, I'm going to go to atoms of carbon now. So I'm going to start with 25 moles of oxygen again. I'm going to go 2 moles of oxygen in 1 mole of my acetic acid. In 1 mole of acetic acid, I have 6.02 e to the 23rd molecules of acetic acid. And in 1 molecule of acetic acid, I have 2 atoms of carbon. Alright, so I times all that out, and I get 1.5 e to the 25th atoms of carbon. And that is the review for your test. Hopefully you do great.